Welcome to Garnik Sutra. This is my first video, guys. Hopefully, you will like it. Now, as this is a first video, I want to make certain things very clear. As you might know, that YouTubers are being considered as the influencers. I'm not saying I'm an influencer, but that's the general definition I heard of it based on my knowledge. So it's my moral responsibility to cover the intent, my inclination, with my biases with my all the audience so that if you decides to follow me to get influenced because of me, you should have a clear idea of what my biases and intents are so that you can take an educated guess whether to follow me or not. I consider this as my moral responsibility. Now in today's subject I wanted to tell you guys on what is math, what are the two philosophies of the maths as per my knowledge, and what is the way, a structured way to learn the applied math. That's the three topics which I want to cover. Hopefully, you guys are ready. Let's start. Now, just to give you a little bit of my background, that if you try to search about I hope that you would have seen my short description on my YouTube channel. Now, if you try to search maths, AI, finance on the YouTube, you usually find two types of creators. There are absolute geniuses which have Ivy League PhDs, and there are few hype men trying to sell you anything related to like a trading pot or a course. I am neither. I'm an average IT guy. In school, I was an average student. I don't have genius IQ. Equation didn't just click for me. But I had one thing going for me is the deep, almost obsessive curiosity about how the world actually works. So I actually keep asking myself that if this physical phenomena is happening around me, that why it is happening. So it's an interconversation with me because I'm coming from a small town where getting an answer to a complicated concepts not that easy. There the time there was no internet, there was no chat GPT who can spit the facts like you are anything. So everything is not that readily available the way we have today. Now, here comes the dark valley. I mean, this journey seems to be very easy, but it is not. Why? Because nobody on this channel will, I beg your pardon, nobody on this particular YouTube community will tell you how lonely self education is because you have chosen your path on the basis of your interest. Okay. So, self education is the only way. You don't have professor to guide you. You don't have hard concept which is running full speed into a brick wall. Now, for years I struggled because it's a self-chosen path. As I said, you try to try to learn, take the wrong learning path. Now, very deep in the learning path, I come to know that whatever learning path I have chosen is basically not the learning path. So you have to scrap what you have learned, and because the intuition was not there. Okay, there is a boredom, there is a depression, that the hard complex problems you are not able to find the answers with. Okay, so in that particular phase there is lot of times waste, lot of time get wasted. Okay, so this the reason behind this channel is that if some average guy is trying to find the answer and don't want to repeat the mistake which I committed, and an average guy like me, then probably he will might face the same problem which I faced in my path, and my experience will help him to structure this particular journey so that he can save some time. That's the main intent behind it. Okay. I will also cover that how I overcome all these things. Okay. But that's a separate topic. And I will surely cover the journey I went through while going through all these particular topics of the complex math. But it's a separate topic, as I said earlier. Okay. Now, there are usually two philosophies in the academics. Okay, it's a long debate. We are not here to debate that what is pure mathematics and what is applied mathematics. Okay, which we're gonna say as the second topic of my slide. Okay, now most of the people who are applied mathematicians, they will come to you and says that math is abstract. Somebody says when math is abstract, it is not harsh to say that math as an individual subject has not that much value if we see maths in isolation. Okay, but when you use any mathematical concept to solve some core problems from a different subject, then that is called as applied math. Because let's consider if you are trying to resolve the what is the acceleration or what is the gravity. Okay, in that case you are using some mathematical force, that what is the force applied when something is coming down, and you are trying to figure it out what will be that quantity is. So you will use the mathematical rules and samples to model that particular gravity. This is applied math. But there is another philosophy in pure maths that they want to say that pure mathematics can be a subject in isolation. They will also give you the way that there are certain mathematical discoveries ahead of any application, and then it has made a lot of breakthrough. Now we don't want to get into this particular def- debate whether it's a pure math or a applied math. As a individual, my inclination is toward applied math, because as we are an executor, as an IT guy, I want that any mathematical concept, I will try to apply that mathematical concept to the real world problem like artificial intelligence, machine learning, finance, computer science. What is the convergence? How ALU work? How ALU calculates the multiplication of two numbers? There is a concept of convergence. So all these topics will be handled using maths. So my inclination is toward the applied math. The whole, and I want to be absolutely sure that if somebody visits this channel, they should be basically well aware of what my inclinations and biases are. Hopefully, guys, that's clear that what my intent, what my bias is, and what are the two philosophies of the mathematics. Now, let's dive into the applied math. Okay. Now, applied math is basically a structured loop. Okay. It has divided into four steps. Okay. First step is the real world problem. Okay. In real world problem, you might receive a problem or you might encounter a problem of different type. Okay, now let's consider the problem can be verbal in nature. Okay, when I say verbal in nature, for example, there is a age variable given to a brother and sister, and you want to find the ages of both brother and sister. Now we will use the simultaneous equation to solve that particular thing. Okay, problem can be diagrammatic in nature. For example, some figure is given in the form of right angle triangle like this. They will give you the angle and they will ask you to model or to find the hypotenuse, which is C. So problem can be in diagrammatic in nature. Second, another way to pose a problem is data. So problem can be in the data format. For example, there can be y, there can be x given to you. Y is 2, 3, 4, and it can be 1, 1.5, and 2. Now somebody will ask you that if I give a value of x, what will be the value of y in future? So you have to find a relation in between these two variables. So on a high level, you might get the problem of this nature. Okay. The second important step in applied math is basically converting this real world problem into a mathematical problem. And this particular branch of mathematics, or you can say a philosophy, or you can say a technique, okay, called as mathematical modeling. Now, whenever you convert a real world problem to a mathematical problem, you have to use one of the method or technique mentioned in the subject called as mathematical model. Now, once you converted the real world problem to a mathematical problem, you have to solve that particular mathematical model, and which is going to be your third step. Now, there are two approaches to solve the mathematical problem. First is analytical method. Second is numerical method or approximation. Now, guys, there are multiple synonyms you will come across the mathematics. It's okay if you don't know, but if you understand the core concept and if you somebody tells you that numerical method is called as approximations, then it means the same. Always during this particular along this journey, if somebody uses certain words, do not get panic. If you are stick to basic, it it's just the another word in the dictionary. Okay, you can you can always go and google it and come to know that what approximation means. And if you know this particular concept and you come to know approximation is nothing but numerical method, you will get that concept. Okay, so I will recommend you to stick to basics, try to understand the concept, and rest doesn't matter much. Okay. Coming back to the subject, now there are two methods to solve the mathematical problem. One is analytical method and the numerical method. Okay, now what's the difference in between analytical method and numerical method? So in analytical method, it's always deterministic. So deterministic means every time you get this similar type of a problem, you will apply this particular method and you will get the exact same solution. So for example, calculating the hypotenuse of a right angle triangle. So you will able to find that using Pythagoras theorem. So if any right angle triangle and you have to calculate the hypotenuse using two adjacent sides, then this formula will always work. The scale of the side doesn't matter. It can be this much, it can be this much. Okay. So every time you get a certain scenario and you have the analytical solution available over there, it will always work. So this will called as deterministic, somebody will call it as closed form solution. Okay. But guys, you have to be very cautious. In a real world, in applied math, picture is not rosy always. You will not have the closed form deterministic analytical method to solve the every problem available in this world. But you have to approximate it. You have to approximate the solution. Okay. And that comes under the numerical method and approximation. Now, once you find it out, what is the solution? Okay. You will try to backtest or simulate this solution using some data, that whether this solution is basically calculated is able to work in the real world problem. Okay. So in that particular scenario, you will use some test data or simulated data or augmented data, and you give that particular data as an input to a solution, and you'll try to find the answer to it. And that process is called as backtest and validate. Okay. If you find it out the results are not up to the mark, you will again start from the step 1 to step 2 to step 3 to step 4. Okay. Till you find a good solution. And once you have this particular solution, which is up to the expectations, you will deploy that into the real world. Now, in case of numerical method, you will not find the exact solution. What I'm saying that in the real world, if you are getting the value as the 3 as the correct answer, and you might be getting is called as 2.98 as the form of your solution. This difference is called as error. And whenever you will gonna use this particular method and approximation, there will always be a error and an appetite of the error. Okay. And that's the beauty of applied math. We are not trying to exactly find the solution, but we are trying to reach up to a good solution which will try to reduce this particular error. Hopefully all these four concepts, four steps are clear to you guys. Now you guys have to understand now every applied mathematics concept. Whenever you read that particular concept, you have to figure it out. That particular concept, is it a part of mathematical modeling? Is it a part of s- solutioning method? Whether it is an analytical method, whether it is approximation or numerical method. Okay. And which is the type of a problem it is trying to solve. So if you read the mathematics in this particular framework, applied math to be honest, then I think that will give you the better intuition that whenever you read any topic, and if you know which part of steps that particular topic belongs to, then you will not assume the initial steps. You will try to explore that if you are trying to read the analytical method to find the side of the hypotenuse, what problem it has poses, how, which mathematical model has been used to convert that particular real world problem to a mathematical problem, and then read that particular analytical method to solve that particular mathematical model, so that you will come to know the end to end process, and you will better understand that concept, or the intuition behind that concept will be developed. Hopefully this video is useful. In the next video I will try to take few problems and will use all these four steps to solve this particular problem, different type of problems. And I'll help you guys to understand that if we try to use this model to read any mathematical concept, that will give you the better idea, better intuition about the topic which you are trying to work it on. Thank you. Thank you for listening.